Solve the following system of equations. If there is a single solution, answer it as an ordered pair, x, y, z. If there are infinitely many solutions, parameterize your solutions in such a way that z is your free variable. Answer using reduced fractions if necessary. So this system is a large system because there's 3 or more equations and there are 3 or more variables. Also, it's a linear system because all the variables are degree 1, which are linear variables. Now, in order to solve a large linear system, what we should take advantage of is the Gauss-Jordan method. Substitution and elimination will work, but they can be rather tedious and prone to error. So the Gauss-Jordan method, what it requires is to write your system as an augmented matrix. In an augmented matrix, you have a number of rows equal to the number of equations, then another number of columns equal to the number of variables plus your constants. So everything in the first column is multiplied by x, everything in the second column are coefficients of y, everything in the third column is coefficients of z, and then we have our constants. But our constants are separated by a line in the augmented matrix. So the coefficient on x's here, we have 1. Then the coefficient on y in the first equation is -1. Then -2z equals the constant -2. And I probably need these a bit larger to get it all to fit. All right, and then in the second equation, it's 2x minus y minus 2z equals -1. And the third equation, I have 0 for x, 1 for y, 2 for z, and 3 for the constant. Now, the Gauss-Jordan method can be completed in the calculator. We'll take advantage of the calculator's ability to work with matrices, and that way we're avoiding the use of using the elementary row operations directly, which also can be tedious and are very prone to error. So what we'll do is, under the matrix menu, we'll enter our augmented matrix. In this case, it is a 3x4 that I need, so I'll leave the size alone, but enter these new coefficients, just like I have written them in my augmented matrix. Now, there's no line separating the constant for the calculator. That's okay. It doesn't make any difference there. It's more of a notational thing than anything important operationally. All right, now just double checking my coefficients. Once those are in properly, I can leave the matrix editor and then run a function under the matrix menu. You go into the math area for these, and you scroll down until you reach a function called RREF. This stands for row reduced echelon form. It is different from REF, so be careful there. Just press enter and then hit second and matrix again. And now we just want to tell it the matrix that we or where the coefficients are for the matrix we just entered. So that was in matrix A, so just highlight that and press enter. And now run the RREF program, and we get this right here. So I have a new augmented matrix, which is 1, 0, 0, 1, 0, 1, 2, 3, and 0, 0, 0, 0, which looks a bit strange. There's clearly not a single solution here because you would have to have the form 1, 0, 0, 0, 1, 0, 0, 0, 1, and then these constants over here would be your solution, your single solution. Let's see what this looks like as a system of equations. So if we convert back, remember everything is multiplied by x in this column, y by this column, z in this column, and these are constants. So it would look like x, those go to 0, and then equals 1. And then we have y plus 2z equals 3. And finally, we have 0 equals 0. Now, this 0 over equals 0 looks funny, but it's not a contradiction. It's just telling us that there's infinitely many solutions. So to express them as a solution, we're told to use z as our free variable. So what that means is I need to write my solution as an ordered triple, x, y, and z, where z is my free variable. So I just leave it alone. Just call it z. That's fine. X is solved for, which is nice. So x is just the value 1. But what is y? Well, y we get from this statement right here, in that if we solve it, we could say this is y equals negative 2z plus 3. And what happens is we get y in terms of the z variable. So negative 2z plus 3. So whatever I choose for z, the y value is negative 2 times that number plus 3, but the x is always 1. And so any coordinate that fits this form will solve this system. And that's how we write the final solution.